Hello everybody and welcome to Machine Learning Part 2. So in this video we're going to be creating a very advanced AI model using Python, GPT-2 and RAG. But before I do that, first let me just go ahead and explain to you guys what is RAG. So I have a diagram here. I'm just going to explain what this diagram is for in a second. But RAG stands for Retrieval Augmented Generation. So how this works is that in RAG is a technique. It's not a library. So we have a this is how RAG works. So first of all, we need to have a data set for our model. So over here, the data set is over here. Now let's say in this data set it has leaves are green, which is the GRE for short. So yep, leaves are green. Now let's say the user asks the model what colors are leaves. So now the model will first look into this data set. It will find the most familiar sentence, and then it will get leaves are green, and then it won't give it to the user directly. It will feed it to GPT-2 or any other model you guys want to use. But for demo purposes, I'm going to be using GPT-2. So we feed it to GPT-2. Now what GPT-2 does, it refines this sentence. So it refines it. So instead of leaves are green, it might say something like leaves are green and lush, and it might fix some grammatical mistakes in the data set. And then after it refines the sentence, then it will throw it to the user. So yep, this is how RAG works. So now let me go ahead and give you guys a demo of what we'll be building. So I have it right over here. So ask a question or type exit to quit. So let me ask it, what is RAG? So as you can see, oh, this is a warning. We could ignore it for now. But let's see. I just wait for it and to return an answer to us. Okay, as you can see, it consists of a RAG model, a simply substance. Like a short answer to the question is okay. Yep, it just explains what is RAG, but I think it has some issues because I specifically didn't mention RAG in my dataset. But yep, you guys get the idea. Let's just say something like what is GPT hyphen 2. So yep, we didn't know this again. So let's just wait for it to give an answer. So it's gonna retrieve it from the data set and then it's gonna feed it. So over here, as you can see, it says GPT is the library. I think it's generalizing over here, but yeah. So now with this, now let me go ahead and actually start coding this out. Instead of going through the code this time, I'm actually gonna code this from scratch so you guys can understand it better. So let's do it. Okay guys, so let's go ahead and get started. So as I said, I'm going to be coding this from scratch. So first, let me go ahead and just classify this our rag underscore gpt.py, and now we're going to import the transformers model. I went through this machine learning part 1, so if you haven't watched that, so go ahead and watch it if you want to understand this better. So GPT to LM head model, and now we're going to import the tokenizer to convert the words into numerical representations so our model can understand. And now we're going to use a library here called oh, no, yeah, from sklearn dot feature extraction dot text. I'm going to explain what this library does in a moment, but just give me a second. And we're going to import the TDF vectorizer. So this will also be used to convert it into numerical representation. So if you guys don't know what the sklearn library is for, it's a machine learning model for Python. And also you could create pipelines in it. So it's based in NumPy and SciSP. So if you guys want to install it, you could go ahead and do pip install sklearn. So, yep, once you have that, let's go ahead and import Torch. I also went through this in machine learning part 1. And then let's go ahead and import NumPy as NP. So we're going to be importing NumPy, but we're going to use it as NP. Alright, great. So we have all the module set up, and just remove the space from here. Okay. So first, what we're going to do is we're going to load our documents. So this is where the model extract its information from. So what we have to do is knowledge underscore chunks. This is gonna be the model's uh like source of where it gets all those things. So yep, I'm gonna do this. And over here we could do something like GPT-2 is a transformer based model. And then maybe we could add something like rag. Wait, let me go ahead and do that again. So rag stands for retrieval with augmented generation. So now let me actually go ahead and on purpose I'm gonna make mistakes in the spellings. So even if I make mistakes, the model will feed it to GPT-2 and then it will fix it and then it will give us a proper response anyways. So yep. So you guys could add more knowledge chunks, but for now I'm just gonna keep it as this to keep everything simple. And so now what we're going to do is we're going to build a retriever. So now what this retriever will do is that whenever the user asks a question, it's going to look into the knowledge chunks in the documents, and then it will find the most similar thing, and then it will feed it to GPT-2, the most similar statement. So now to do this, what we have to do is vectorizer will be equal to TF-ID vectorizer. So now the document vectorizers will be equal to the vectorizer dot fit underscore transform. I'm just going to explain this in a second of the knowledge chunks. So now what's going to happen, now this vectorizer is just going to be to convert these words into numerical representations. And now this doc vector will go ahead and it will fit transform. This is a built-in function to these knowledge chunks, which are over here. So, okay, now what we're going to do is we're going to define a function to retrieve the documents. And now this is going to have two parameters, query, the user's query, and top k. So top underscore k will be equal to 3. So now what this top k is for is that it's going to retrieve the top 3 most similar statements in our knowledge chunks, but we don't even have 3 over here. So let me go ahead and actually just add 4. So let me just say Tesla are electric cars, and let me go ahead and add, wait, you have to add a comma here. So yep. Now let's just go ahead and do what else could we do? Maybe Antarctica is cold. So yep, that should be good. That's 4. So now it's gonna return the top 3 most relevant things. I mean statements. So now once we do that, we could go ahead and add a colon. So now the query vector is gonna go to the vectorizer and transform this. Yeah, it's gonna go into vectorizer. It's gonna transform this into a query. So this function is gonna be very complex. So I'm gonna actually go ahead and explain it in depth after I finish writing it down. So scores will be equal to the doc underscore vector, and we're gonna find the most similar. This over here is gonna compare the doc vector and the query vector, and it's gonna find the most similar statement. So sorry, query underscore vector. Yep, there we go. Dot t. So what t dot? Wait, give me a second. T dot 2. All right. So yep, I think that should be good. And now what we have to do is we have to flatten this. And then we're going to return the top indices. So top underscore indices. Wait, let me fix this variable here. Will be equal to the score dot args sort. And now, oh wait, yep. Oh, sorry, it has to be scores. My bad, because over here we defined as scores, not score. So let's go ahead and now actually we're going to do top k. We're calling this parameter over here. So top k. Um, we're going to also over here add negative. Sorry, yep, it's a slice. So colon minus 1. Yep, and now we're going to return knowledge chunks for I and for I in the top indices. So let's go ahead and do that. Do this again. So for I and top indices. So I think that should be good. We have to actually add this over here just like that. And now that should be good. So now let me go ahead and actually go through this whole function. I think this is the most complex part, so all the other functions and code should be pretty easy to understand, but yep, this one's very complex. So over here we have a query, the top three most relevant responses from the knowledge chunks. We have the query vector, and now this what this scores is for that is gonna compare this document vector, this one, the documents basically, and the query vector. The query is what the user types. It's going to compare them, and over here it's going to find the most similar response. It's going to get the most top answers. It's going to sort them, and then what this is going to do is it's a slice, so it's going to flip them around to get the highest scores. And now we're going to return the knowledge chunk from the top indices, the top statements it fetches from the document. So yep, once we do that, let's go ahead. Now this part should be pretty easy because I also did this in machine learning part 1. So now what we're going to do is load the GPT-2 model and the tokenizer. So, okay, so once we do that, we can do tokenizer. It will be equal to the GPT-2 tokenizer and dot the pre-trained from the pre-trained model GPT-2. So, yep, once you do that, we can also have model. It will be equal to GPT-2 LM head model, this one, and that from pre-trained, pre-trained, second, yep, pre-trained GPT-2. So, and now what we're going to do is model dot. So now what's basically happening here is we're importing the tokenizer to convert this and to convert these words into representation so the model understands. And over here we're just loading the model, and over here we're using the eval function, the model. So now, as I mentioned before, when the user asks a query, for example, what is brag, it's going to go ahead, it's going to get this, and then it's going to feed it to GPT-2 to fix any grammar mistakes, and just refine the sentence to make it better. Then it's going to throw it at the user. So, yep, that's how it works. So now what we're going to do is that this is actually optional, but I know some of you guys are really on GPT-2, I mean GPU, so we could speed it up with GPU. So let me just go ahead and do this. So if torch.CUDA dot is underscore available, what we're going to do is that the model will be follow.CUDA. Okay, so yep, so if GPU is available, then the model will use GPU. It's optional. Let me just now what we're going to do is we're gonna combine. We're going to combine the retrieved documents into um a, the retrieved documents in query into a prompt. So now so once we fetch it from here, we're going to combine it with the query, and then we're going to return a good prompt. So now let's go ahead and define a function here. So def build prompt. This will have also two parameters, context chunks. So this will be the chunks from the knowledge chunks or the documents and the query. So once you have that, we could do context equals to, I'm going to explain this in a bit too. In the new line, sorry, give me a second, dot join is going to join in with the context chunks. And then we're going to say prompt will equal to um, we're going to use the fstring function, and then context backslash n, and then another backslash n. Question will be the query, basically query, and then backslash n the answer, will will equal to no with the answer, and then I'm going to just return the prompt. So yep, what's basically happening here is that we're just gonna get the context, the whatever the user types, and then we're just gonna return the question the user types, and then for the answer, we're just gonna return the prompt it gets. So it's gonna build a prompt like that. And now what we're gonna do is we're going to generate an answer using GPT-2. So let's create a function to generate an answer. It will have prompt underscore max length will be 150. So what this max length is for, I think I also mentioned this in machine learning part one. So to how many characters the model can reply. So for example, if the model is replying more than 150 characters, it won't let it. It'll just stop at 150 characters. You can do this 150,000 or anything you guys want. I'm just gonna leave it at 150 for demo purposes. So what we're gonna do is we're gonna do inputs. It will be equal to a variable tokenizer dot encode. We're gonna encode. I also mentioned this in machine learning part one. So the tokenizer will encode this into a prompt, and then it will return tensors, which will be equal to the PT. And now we're not gonna actually end it here. We're gonna have a comma, and function will be equal to true. So yep, no, yeah, this has to be capitalized. So yeah, I think I spelled this right. Yeah, I should have an A over there. Yep. So once you do that, you could also have a max length for this. So max underscore length for this will also be anything you want. So I'm just gonna do 1024. So this input, so whatever the user types, like the input, when the user gets their max length will be 1024. So yeah. Now what we're going to do is if torch.cuda dot is available. I also did this before, but we can do it again. Because because now we're using GPT-2, so we might have to do it again. So inputs will be from inputs.cuda. So if the user's input is from GPU, then if GPU is available, then the user's inputs will also be from GPU. And now I'm gonna use the with function here. So with torch dot no grad, sorry, no grad. We're going to go ahead and add here. So the output will be, so if it's not GPU, then the output will be uh the model, sorry, model dot generate. So the model will generate a response. So we have to do this input, and then we're going to have max underscore length will be equal to inputs dot shape. Put this for 1 plus the max length. So all of these things for all of these things I'm doing here, I've already went through this in depth in machine learning part one, except for this, which I have already explained. So yep. So let's go ahead, and now we're going to do sample equals to true. I also mentioned this. And now we're gonna control the model's creativity and deterministic. So top P will be equal to let's do, I'm actually gonna keep it low for now, so 0.95. So meaning the model will be more deterministic. If you want your model to be more creative, you could just do 95 or something. I'm just gonna leave it at 0.95. So the top K. I'm just gonna also leave a little creative here, so 50. And now we're just also gonna have the temperature, important one here, which will be 0.8. Okay, so let me go ahead and do that. So now what we're gonna do is EOI. Did I create a variable for this? I think I did. So EOS underscore token ID will be equal to the tokenizer Sorry, I think I spelled tokenizer wrong. So tokenizer. And wait, give me a second. Tokenizer dot EOS token ID. And yep, think this should be it for this output variable. And now what we'll do is full underscore output will be equal to tokenizer dot decode. We will decode the output so the user can understand it. So we're going to convert it from numerical representations to words so the user can understand. So when the model returns in response, it's going to be in numerical representations, right? So what we have to do is that we have to convert it into words, basically decode it so so the user can understand. So now what we're going to do is we're going to skip some special tokens here, so because we will not need those, and we'll set it to true. Skip. Yep. Now return the full output. We're going to return output. The place. I'm gonna strip out the prompt. So what's gonna happen is that once the user, well, I mean, once the model returns a full output, it's also gonna include the prompt. So we have to replace it and we have to strip it out. So, yep. That should be good. Now what we have to do is we have to create a RAG pipeline. So full RAG pipeline. Sorry, I think we don't need that much indentation. Yep, okay. So let's define RAG pipelines. We'll have one parameter, query, and then we're going to do retrieved docs will be equal to retrieve documents from the query, based on the query. So now the prompt will be equal to build underscore prompt, the retrieved docs, and the query. Alright, so now we can go ahead and print this F function, and then a backslash n hyphen hyphen the prompt, and then just like that, backslash n, and then we're gonna print the prompt just like that because that's the reason we used it. Another backslash n. So yep. Now once the user types a prompt, we're just gonna print the user's prompt over here, just like I think I showed in my demo, just right here. Over here, as you can see, we just print the prompt just like that, just to get the user a better understanding. So yeah. So once we do that, we could go ahead and return the answer. So no, actually before we return the answer, we have to do answer equals to generate the answer prompt. So now what we do is we're gonna return the answer finally. Yep, yeah, I think that was gonna call. So now what we have to do is we have to test the pipeline. So to do that, we have to do if underscore underscore name underscore underscore is equal to underscore underscore name underscore underscore. So this is actually a very common. Oh, sorry, we have to do two variable signs. So this is actually very common even in Flask. So once you're doing this, you just have to do this to clarify the name, and then once you have to do, you have to have while we can have a while loop here. While loop to keep the chat going between the user and the model. So user input will be equal to input, which will say, which will have a backslash n, and then ask question or type exit. So if the user underscore input dot lower, so lower function in Python, you make sure to put parentheses is equal to exit. We're going to break the chat. So if that's not the case, what we're going to do is we're going to do response will equal to RAG underscore pipeline for the user's input. So we're calling the RAG function over here. and the response, so it will run the RAG pipeline based on the user input, and that will be the response for this. So, sorry, let me remove this terminal. Okay, it just keeps coming in the way. So, yep, okay. So if I do that, now what we can do finally is print the user's response. So print, we could have F, we could have F here. So \n GPT happened to answer colon will be a \n and the response. So, yep, we are done. We have successfully built a AI model using Python, RAG, GPT-2, sklearn, NumPy, Torch, and many other libraries. So, I hope you guys had fun building this model. So, let's actually go ahead and test it out. So, it's called Python. No, this one's called test.py. Yeah, Python test.py. So, let's go ahead and test this model out. Yep, it's gonna take some time because I am on CPU as I mentioned before. Let's wait for it to finish. And meanwhile it finishes, let me just let you guys know that I also have the full code on GitHub. So I'm gonna put the link in the comments so you guys can go ahead and get the code from GitHub if you want to. Wait, where is it? Okay, yep, as you guys can see, it's about to start. There we go. Ask a question or type exit. So what is RAG? Okay, so function object has no attribute fly. And so let's go ahead and actually look at what happened over here. So I've actually fixed all the issues that we have had. So the first issue over here was that we misspelled truncation. So go ahead and type it like that. And also we misspelled temperature. Just some small typos here. And also one more thing. Over here, we kept these top K and minusing the slice in a new line, but we had to keep it right next to this ARG sort. And yep, and we had to return the full output with the length of the prompt. We just did it with the prompt. So yep, but I have fixed all those issues, and now our model should work properly. So we'll ask the question or type exit. So what is RAG? So as you can see, it's kind of working. So we could bring this warning, as I mentioned before in machine learning part 1, we could ignore it. And I also mentioned earlier when I was giving you guys a demo. So as you guys can see here, it just returns the answer. It's not trained that much, so that's why. But and also if I type exit, it will quit. So yep, this is pretty much it for this video. And in machine learning part 3, maybe we'll create AI model with a GUI with Streamlit, probably using RAG or maybe something else. But yeah, we'll see. Let me know in the comments, and I'll thank you guys very much for watching, and I'll miss you guys in another YouTube video.